on tutorial number 12. Okay, tutorial number 12 with the introduction what we had, it is a bit easier for us to solve this problem. Now let us see what he has given. He has given me a cantilever beam, and see the beam is like this and everything is on the left side. Okay, no problem. We have the symbol. So what is the first job for the solution? You have to write the sign convention. Okay, you have to write the, don't forget to write the sign convention. This is the first thing before you solve the problem. Right side downward is positive, left side upward is positive. Then the opposite of it is negative, the opposite of this one is negative. Okay, this is your shear force. Whatever bending moment I said, this is positive and this is negative, irrespective of your boundary. This is what, this is your bending moment. This you keep on the corner, okay? In the corner. Now let us start the problem. So what he has given me, he has given me the weight. This is 4 kilonewton. How many meters are there? 2. Then how much is the total load here? 8. 2 there are barbar, is it? 8 kilonewton. So what can I do now? I can just, where it will act exactly in the middle, is it not? I will just put a mark like this, okay? This is for meter. I write dash dash dash. This means what? This is not the given force. This is the total of this 4 into 2, okay? This I can simply say 8 kilonewton. So what is the next job? As I said, don't write anything below this. Draw lines like this. Draw a line here. Draw a line here, okay? Leave it like this. Now our solution will be here. Okay, sure? Now let us start. What is the first thing I need to do? I need to come to shear forces. Shear forces. So what should I do? I will take the plane. I will take the plane. Okay. I keep my hand there anywhere. Just put here. Put here. Okay, Shabab? Put here. So what is the force on this side? So now here you see, you already have. See, what did we say here? Any plane. See, what is the length? We said it is acting somewhere here, isn't it? Now let's try to just come here. Shear forces. Shear force at A. Or I will say shear force at shear force at XX. I just put a plane here, somewhere like this. Okay. What is this distance? This distance I will call as X. I will call as X. Okay. What is the shear force at XX? I'm keeping my hand here. Remember, I'm keeping my hand here. Left side downward is what? Check your sign convention here. Left side downward is what? Negative, is it not? First of all, write negative sign. Don't miss this, okay? This is your plane. I am not checking on this side. I am checking on this side. No doubt, you can even check from the right side also. There is no problem, okay? But since if I take on the left side, I have very little forces, no problem. Understand? So now what is the force here? 4 multiplied by what is the distance? X, isn't it? 4 multiplied by X. It is like this. Can you come here? See, the problem is exactly like this. Understand? The problem is exactly like this. See here? This is the uniformly distributed load, and there is 1 kilonewton here. Understand? Clear, Shubham? So what is this one? 4 kilonewton per meter. How many meter I have? I have 2 meters. Is this clear? If I keep only here like this is my XX plane. Understand? This is my XX plane. So what is the force here on this side? W multiplied by X. This is the load, isn't it? If I go to this point, it becomes how much? W multiplied by 10 meters. Isn't it? X will become 10 meters. Correct? If I am here, what is X? 1 X. X is 0. Is this clear? If I am here, whatever is the x, I will write. Understand? Clear now? So now what I will do now, I will just say minus 4 into x. So when x becomes 0, so what will be the value of the shear force? 0, isn't it? When x is equal to 9 meter, what is shear force? Minus arba multiplied by 9, that is minus 8 has a kilonewton, is it? Let me write it as kilonewton meter. Okay. You're dreaming. Now let me draw a line here. When x is equal to 0, what did you get? 0. And what is the power of x? The power of x is 1 here, see. So it should be what? It should be a straight line, isn't it? So now when x is equal to 2, you have minus 8. Where is minus 8? Maybe here. Maybe here minus 8. Okay? Agree with me? So it is what? It is a straight line. This is minus 8 kilo. This side minus 8 kilonewton. Okay? You came here. So now what should I do now? Now between B and between C and D, is it? Shear force between C and between C and D. C and D is how much? Can you again come back, please? See, I have this one here and I have this force over here. Okay, this is my what? This is my C, is it not? Any point here. Mashallah, here is strong muscle, no problem. Okay, how much is this? 4 multiplied by 2. This is 7, is it not? This is 7, yeah. And this is how much? 1. Khamsa. Okay, anywhere here you have how much? Khamsa, acting downward, is it not? Acting downward. You agree with me? So now what I will do, I will simply say between A and B is how much? Minus 4 multiplied by 2 minus 1 now, is it not? This minus sign because both of them are acting downward. Okay, sure. This becomes how much? Minus 8 minus 1, that is minus 9 kilonewton meter. You agree with me? Between C and D is how much? Minus 9 kilonewton meter. See, at this point, because of this load, suddenly from 8 you went down to how much? Minus 9 kilonewton meter. Okay? You stay constant. Understand? So, if you are sleeping, I will get you here now. Next. Now, there is a reaction here. We all know that there is a reaction force here. Correct? There is an RB. This RB should be equal to this much. You already have it there. Okay. If I go beyond this point, what will happen? It becomes 0. See here. This is what? This is your shear force diagram. See there. How does it look like? You can very clearly see, isn't it? How gradually it is increasing and how it is constant. Okay. So now whatever material you select, this material should be able to take up this shear force, understand? Without failing. This is the idea, understand? Now let us go to bending moment. Bending moment. So what shall I do now again? We get our friend here. Poor guy, he is sitting very close to me, so he has to suffer badly. Many times he needs to come now. I have put this force here. I have made it over here. So what is the bending moment here at this point? If I want to take, there is no force, there is no distance, isn't it? 0, correct? Agree or no? Okay. So now, bending moment, that is one point. And then what I will do, another one. Stand there, no problem. Okay. I will just come over here. This is my plane, understand? This is my plane. What is the bending moment at this plane? force multiplied by perpendicular distance. Correct, Shabam? Force is how much? This is W multiplied by this distance is X. Correct? Multiplied by where it will act? In the middle, is it not? X by 2. Solve the law. Agree with me? So what I will do now, this plane is there, this is acting here, this is supposed to be through the middle point, is it? So bending moment at A is equal to 0 anyway. So let me just come down here. This is 0, okay. Now bending moment at plane XX, because you have XX here, so I will take bending moment at XX is equal to how much? What is the force? It is trying to bend down, isn't it? It is trying to bend down. So what should be the sign? See here, bending down is negative, correct? Negative. 4 multiplied by x. This is your force, correct? Where it will act? It will act through the midpoint. How much is this distance? This will be x by 2. That's what I showed you here. If I have a plane here like this, if I keep the plane, W multiplied by x, where it will act? Through the midpoint, x by 2. Correct? Multiplied by x by 2. This becomes how much? Minus 4 x square by 2. Correct, sir? 4 x square by 2. That is nothing but minus 2x square. Let it be that. Okay? Correct, sir? Now, when x is equal to 0, what is bending moment? Close your eyes and put 0. It multiplies it. You got 0, isn't it? It's already 0 there. Now, bending moment. I need not have to have this one, okay? Because already when x is 0, I am having it. Let me remove this one, okay? Let me remove it. Then when x is equal to how much? X is equal to 2, because uniformly distributed load is only for this much distance, isn't it? Only from here to here. Don't take here, okay? Between here to here only, right? X was 0 and x can become is equal to 2, isn't it? When x is equal to 2, what is bending moment? Minus 2 into 2 square. Minus, how much does it become now? Did we make some mistake here? I need to just check. Give me 1 minute. 4 into x. Did I write 4? Yeah. 4 into x multiplied by x by 2. It is 4 x square by 2. Okay. It is minus 2x square, right? Minus 2 into x square, okay. Okay. It's about 8 kilonewton meter. Is this clear? So what I will do now, I have to just write it down. See, what is the benefit of having this graph and writing in terms of x square is very easy for us now. Initially it was 0, we write it. Next value is how much? Next value is minus 8 kilonewton meter, isn't it? But what should be there? It should be a straight line or a curve. See here, what is the power here? Power is 2. It is square. It is a parabola. Understand? It is a parabola. Okay, it is a parabola. It should be a curve. Remember, when you have a horizontal line, you will have an inclined line. Understand? When you have an inclined line as a shear force, your bending moment will be a parabola. Understand? Clear? So you have this one. Now what do I need now? I need to find out bending moment at any point. Let me take P because there is no force here. Okay. So I will just go, I will say bending moment at B. Now how much, what is the bending moment at B? I will not call my friend, I will take myself. Poor guy, he will cry. Okay. How much is this weight, I think? Arba darab itne, is it not? Arba darab itne. Correct. The minus, huh? Where it is acting exactly in the middle point. Correct? So what is this distance from here? Please all of you look here, don't write. Let's look at me. Okay. It is there anyway for you. How much is this distance? This is how much is the half point? 1. Is it? And this becomes how much? Arba. Arba darab tamaniya. Is it? This is tamaniya. Arba darab tamaniya. It is acting down, bending down. Isn't it? So what I should do? I should write minus tamaniya darab talata zaid wahid. Is it? Arba. This is one force acting downward. Correct? Agree or no? Sure? What you are? Here and there. This is Arba. For wahid meter. Itne meter. Any tamaniya. This is wazan tamaniya. Where it is acting middle point. Correct? Middle point and this is how much? Wahid meter. Because total is itne meter. Middle is other wahid meter. Zaid talata. It becomes Arba. So I write 4 meters. Okay. Now there is one more force which is acting here. This force is how much? 1 kilonewton. Does it not? 1 zarab how much? Talata. 1 zarab talata. Okay. This is also acting down. Yani minus. So I will write minus 1 zarab talata. How much is this? Minus 32 minus 3. This becomes minus 35 kilonewton meter. Okay. Kilonewton meter. Minus 35. Somewhere over here I will draw a straight line like this. Wherever it is cutting, I will write minus 35 kilonewton meter. Okay. This is bending moment. This is bending moment. See that? How it has gone, you can very clearly see. If you really see big structures of buildings and the bending moment and shear force diagram, they look so beautiful. Understand? Where maximum bending moments are there, at which point the bending moments are 0. This is clear. You can very nicely see. Even in your textbook, you can see. There are many solved problems with the bending moment and shear force diagrams. They really look so nice. Is this clear? This is your tutorial number 12. Please.